Today we will start the second chapter, Introduction to Linear Polynomials. So, before moving into the chapter, we will check what you mean by the polynomials. We will go through the basics, then we will go through the exercise questions. So, as you all know, polynomial is a mathematical expression which is made up of variables, constants, exponents, and it is combined using addition, subtraction, multiplication, and division. The key rule is that the exponent of variable must be non-negative integers. So let us go into the definition first. So as you all know, polynomial is the expression that is made up of variables. So variable means the unknown values which can be expressed with any alphabetical letters like A, B, O, X, Y, P, Q, anything can be unknown variables only. Now we have different types of polynomials we have learned. For example, this 5x plus 3. Considering this one, we know that the unknown variable is x here. Now, what is this 5? Yes, 5 is the coefficient. The number that comes along with the variable is called coefficient, isn't it? Now, what about this 3? 3 is the constant term here. 3 is the constant term. Now, like this, we can write the mathematical expression which is made up of the variables, constants, exponent, and we combine it using addition, subtraction, whatever be the operation in it. Now, there is a key rule that the exponent or the variable must be non-negative integer. What does it mean? Actually, if we consider another expression like root y plus 3, will it be a polynomial? It won't be a polynomial because this root y means y to the power 1 by 2. As you know, root y means y to the power 1 by 2 only. So it will be y to the power 1 by 2 plus 3. So you can see the exponent of the variable become 1 by 2. It is not a whole number, right? So the key rule is that it must be a non-negative integer. So otherwise you can remember like that. It should be in the numerator. Like that also you can remember. For example, if I consider y to the power negative 1 plus some 3. Okay, so how we can express this? This is 1 by y plus 3. Will it be a polynomial? It won't be a polynomial because you know that this power of the y is minus 1 only. So both of this won't be a polynomial since the power of the variable is not a whole number. Okay, so remember this condition. A mathematical expression will be a polynomial if the power of the variable or exponent of the variable is a whole number only. Okay, now since you got the idea what is a polynomial, and we have to remember one more thing. You have to just take care of this power of the variable only. Doesn't matter what will be the coefficient. For example, if I consider 5.3x square plus 1 by 2 x plus some root 3. Will it be a polynomial? Yes, it will be a polynomial because you know that the power of the variable here x is the variable and the power of the variable is x square and it is 1 only, right? So this is really polynomial. Doesn't matter what is the coefficients are. The coefficient of x square is 5.3. It's a decimal number. Coefficient of x is a 1 by 2. It is also a fraction and it is an irrational number constant. So it doesn't matter what the coefficient and constant. You have to make sure that the variables power is a whole number. Got the idea? Okay. Now let us divide the polynomial based on the number of terms and the degrees. Okay. So first of all, we will differentiate based on the number of terms. So considering the term this 5x plus 3 itself, how many terms it has? It has two terms. This 5x is the first term, 3 is the second term. Okay. If a polynomial contains two terms, we will call it as a binomial. Binomial polynomial. Okay. If it has two terms, it is called binomial. If it has only one term like x, y, or a constant polynomial 3 or u, whatever, it's got only one term means it will be monomial. It is a monomial. Now, if it has three terms, for example, 3x cube plus 2x square plus 1. How many terms? 1, 2, 3. It has three terms. Three term means it will be trinomial. It is a trinomial. Got the idea? According to terms, we have differentiated the polynomial. If it contains only one term means it will be a monomial. If it contains two terms means it is a binomial polynomial. It's contains three terms means it is a trinomial. Got the idea? This is how we will differentiate the polynomial based on the number of terms. Okay. Now, if any term with four or more terms, we will call it just a polynomial itself. If any term with four or more term, we will call it as polynomial itself. Okay. Otherwise, if it is one term, it is monomials. Two term, binomial. You can consider as binomial itself. And if it is three term, you can consider it as trinomial. Four or more term, it's polynomial. Got the idea? Okay. Now we will move the differentiation of the polynomial based on the degree. So before that, what do you mean by a degree of a polynomial? It is the highest power of the variable. It is the highest power or exponent of variable. Okay, so we will consider a few examples. For example, uh, 3x. 3x means you know that x to the power 1 only, right? If 3x to the power 1 means the highest power of the variable is 1 itself. So here the degree is 1. If degree is 1, what can we call it as? Linear polynomial. This is what we are going to study in this chapter. Linear polynomial. Okay. General form is like ax plus b. Okay. Where a is the coefficient of x and b is the constant. Now moving to the next one. What it is? Degrees 2. Degrees 2 means the general format will be ax square plus bx plus c. Okay, so if 3x square plus some 5 or 6x square plus 5x plus 9, all these are example of degree 2 polynomial. Okay, so if it is degree 2, we will call it as a quadratic polynomial. It is known as a quadratic polynomial. Got the idea? Now, if we consider as degree 3, its general form will be ax cube plus bx square plus cx plus d. It is called cubic polynomial. Say cubic polynomial. Now, if we doesn't have a degree, I mean degree is 0. Okay, for example, 3 means we can write it as 3 into x to the power 0 because x to the power 0, any number to the power 0 is 1 only, right? So this is a constant polynomial. Constant polynomial. Okay, so we have differentiated the polynomial based on their degree. If the degree is 0, we will call it as constant polynomial. If the degree is 1, we will call it as linear polynomial. If the degree is 2, we will call it as quadratic polynomial. If the degree is 3, we will call it as cubic polynomial. So this is the basic differentiation of the polynomial based on the degrees. Okay, so these are the basic concept that you have to understand before moving into the exercise. Got it? Now we will move into the exercise. Once you got the concept, the exercise will be very easy for you. Exercise at 2.1. The first question is like find the degree of the following polynomial. Seems to be very easy. What do you mean by the degree? Degree is the highest power of the variable, right? So the first question is 2x square minus 5x plus 3. So x square is the highest polynomial, right? Or 2 is the highest power of the variable x. So its degree is 2 only. Now the next polynomial is based on variable y. It's like y cube plus 2y minus 1. So the highest power of the variable y is 3. Y cube is there. So its degree is 3. Now what about 9? We told that if it is 9, we can write it as 9 into any variable if we consider x to the power 0 only, right? And what is the name of this polynomial? This is a constant polynomial. So the power of the highest power of the variable will be 0. So the degree will be 0 only. Got it? Now what about the fourth polynomial? What kind of a polynomial it is? It is a linear polynomial because the highest power of the variable set will be 1. So it is the degree 1 polynomial and it's a linear polynomial. Got the idea? Okay. Now we will move to the second question. Question is write the polynomial of degree 1, 2 and 3. It's very easy question because you can write infinite number of polynomial with degree 1, 2 and 3. First of all, we will just check what are the general forms once again. If it is degree 1, general form is like ax plus b. If it's degree 2 means what is the general form? Ax square plus bx plus c. If it is degree 3, it's a cubic polynomial. Its general format is ax cube plus bx square plus cx plus d. Doesn't matter that you have to write all the terms like bx square plus cx plus d in a cubic polynomial. If you just write an example like x cube itself, this will be a polynomial of degree, because the highest power of the variable x seems to be 3 here, so it's correct. Or you can write some 3y cube plus 5x plus 3. This is also an example of cubic polynomial. It's up to you. You can write. You have to make sure that you're writing a polynomial of degree 3 means you have the highest power of the variable should be 3. Okay. Now, if we considering a polynomial of degree 2 means if we consider x square or y square itself, it is a polynomial of degree 2 also. So, if we consider another example like 0.1 x square plus x plus 1 or 5x square plus 3x plus 2, whatever it be, it will be quadratic polynomial only because its degree is 2. Now it's linear polynomial. Degree of the polynomial is 1 means we can consider this 5x or 10x plus 9 or 3y plus 0. Whatever be all this case, you understand that the degree of the variable is 1 only. So all these are example of a polynomial. 5x, 10x plus 9, 3y plus 0. All these are example of a polynomial with degree 1. So I hope it is clear for you. You don't have any doubts in this. Okay, if so, we can move to the third question. Okay, so third question is like that. You have to write the coefficient of x square and x cube in the polynomial x to the power 4 minus 3x cube plus 6x square minus 2x plus 7. Right. So let me rewrite the polynomial. X to the power 4 minus 3x cube plus 6x square minus 2x plus 7. So as we told, coefficient means the numerical value that comes along with the variable, right? So you have to find the coefficient of x square. X square means this is the term x square. So the term that comes along, the numerical value that comes along with the x square is 6. This is 6, right? 6x square means coefficient of x is 6. So you can write coefficient of x square is plus 6, positive 6 only. Now consider the coefficient of x cube. So here x cube is like minus 3x cube. Minus 3x cube means the coefficient that comes along with the x cube is minus 3. So coefficient of x cube is equal to minus 3. Good, that is very easy. Whatever be the number that comes along with that particular variable. For x square means you have to check which is the number that comes along with x square. That will be the coefficient of x square. Got it? So the coefficient of x square is 6 and coefficient of x cube is minus 3. Okay, hope it is clear for you. Now we will move to the next question. Fourth question, what is the coefficient of z in the polynomial 4z cube 5z square minus 11? It's a nice question because the term z is not given directly, right? See, 4z cube 5z square minus 11. Do you have a term with z? Z cube is here, z square is here, but z is not given directly, right? But we know that z to the power 0 is 1 only, right? Z to the power 0 is 1 only. So the coefficient of z 0 will be 11 only, because 11 into z to the power 0 will be 11. What they are asking here is the coefficient of z here. Since we don't have a coefficient of z, we can write it as 0 into z only, right? Like 4z cube plus 5z square minus 0 into z minus 11 into z to the power 0. Z to the power is 0 is 1 only. So if you are getting confused means no need to even take that. You can just take it as Z11 itself. Okay. So when you considering the coefficient of Z means it will be 0 only, because 0 into Z is 0 only. That's why it's not directly given here, but the coefficient of Z will be 0. Coefficient of Z will be 0. I hope it's clear for you. Now we will move to the fifth question. What is fifth question? Fifth question is asking like, what is the constant term of the polynomial 9x cube plus 5x square minus 8x minus 10? So constant term means, yeah, it will be minus 10 only. That's come with along with z to the power 0. We already discussed that constant term is a term with degree of the variable should be 0 only. You remember degree of the variable should be 0 only. So if 3 means 3 will be the constant term. Okay. So here 9x cube plus 5x square minus 8x minus 10 means the constant term will be minus 10. Got the idea? The degree of the variable should be 0. Otherwise, you remember like that. It's a numerical term that doesn't contain the variable. Okay. So anyway, the constant term is minus 1. Got it? So what did we learn today? We learned about the very introduction of the linear polynomial. First of all, we discussed what is a polynomial. So we learned that it is a mathematical expression which is made up of coefficients, variables, exponents, and it's combined using addition, subtraction. But how to remember is like that the power of the variable should be a whole number. Then we have learned that according to the number of terms the polynomial is differentiated, like binomial if the two terms, monomial only one term, three terms are there, it's called trinomial. There is more or four or more terms, it is known as polynomial. According to the degree also we differentiated. If the degree of 0 means it is a constant polynomial. Now, if the degree is 1 means we will tell this is a linear polynomial. That is about this chapter about. Now, degree is 2 means it is a quadratic polynomial. Degree 3 means cubic polynomial. So, according to the basic concept, we have solved the exercise 2.1. So, hope it is clear for you. If you have any doubt, you can ask in the comment box. Okay, so we can wind up for today. We will see the next class with the next exercise and related concept. Okay, thank you. Bye.